What is going on, guys? Welcome back to another video right here on the channel. If you guys are new here, go ahead, drop a like, subscribe, all that good stuff. As you probably know, TurboWarp is a modified version of Scratch where you can actually load custom JavaScript extensions just like this one, where you can actually import OBJ files, render them on the canvas or on the stage. In today's video, we're going to be doing, first of all, like first-person looks. I'll probably get to third-person stuff in a future video. And also, something that I keep seeing in the comments is like gravity or like jumping like this. So I will try to cover that in this video just real quick. What you're watching right now is made completely in TurboWarp. And this is actually an infinite world here. Like you can go literally as far as you want to, and it's just going to keep generating terrain. And so I'll show a little bit on this later in the video, but for now, let's get to the basic stuff. So in the last video, this is basically what we made. Right here we've got, and actually I'm just going to reload real quick so that we don't have all the extensions loaded here. So this is what we made in the last video. If you didn't watch that, I highly recommend watching it. Basically, we loaded this 3D map into the world, and we actually have collisions, like we can't run into any of this furniture right here. The way that we did that, if you watch that video, is with sprite collisions. So it's actually just a 2D plane, and we are basically interpolating where the player is at into the 3D scene that we have loaded here. And that is pretty much all that we have for that. So first of all, gravity and jumping. And this map is kind of weird because it almost seems like it's like tilted a little bit. So I might fix that real quick. -5, -3. So now it's a little more flat. You know, it doesn't feel like the house is tilted. But setting up jumping is actually pretty easy, especially when we have something like this, where it's just a flat ground level here that we're standing on. So on our player sprite here, all that we have to do is we're going to create a new variable, and we're going to call it player y, and then we are going to pull out a new when I receive block, when I receive hitboxes, and if you remember from the last video, that's running every single frame, so we don't need to put it in a forever loop. If the player y is less than 0, just leave that how it is. We are also going to make another variable for the sprite only, and we're going to call it player y velocity. So we can set both of these variables to 0 when the project starts, just so that it's reset. So 0 is going to be the base position that we are at. And what I mean by that is if we are looking at this house from the side, this right here would be the floor, and the position 0 essentially is just going to be when the player is standing right on that floor. So anything below the value of 0 is actually going to be clipped into the floor, right? Anything above obviously is going to be above the floor, if that makes sense. So if the player y is less than 0, which again, that would mean that we are under the map, we're going to have it set it back to 0, and we are also going to have it reset the player y velocity. And actually, we're going to change this to an if-else, okay? So if it is not less than 0, aka it's greater than 0 and the player is above, what we're going to want to do is change the player y velocity by -1, and every frame here we're going to change the player y amount by our player y velocity, and we are also going to be setting player y velocity to itself multiplied by, we can do 0.9. Just put that right above there. So right now, this actually isn't going to be affecting the 3D world at all. So we're going to implement that real quick. So I'm going to the 3D engine sprite. So find the controls block. So right here where it is 0 minus the cam y, we are just going to put 0 and then 0 minus that new player y variable and just put it right there. So now we can drag out a variable block for player y, and we'll just set it to 30 to test it out. And as you can see, it puts us above the ground and we fall down, okay? Pretty straightforward. Let's implement jumping. So obviously we only want to be able to jump when we are actually on the ground or below the ground or the floor. For the jump control, we are going to want to put that inside of this if the player y is less than 0, because again, remember, that is basically saying if the player is on the ground or below it. So if we're just going to do key space, the space bar, then we can go ahead and set our player y velocity. We're going to just try out a value. So I'm going to try 20. Restart again here. And as you can see, we are jumping. Obviously, it is a little much, I would say. So we can set this to a lower amount. Let's try 5. And we can have this right here, which is essentially just the gravity variable. We can set this to minus 0.5. And that's a little better. I might set it down even more. So there you go. We have gravity right there. And since this is a lower value, I'm also going to increase this. This is basically just smoothing it out. So 0.97, we'll try that. And we can set this to maybe like 3. So there you go. We still have the collisions, but now we can jump. Obviously, we cannot jump on top of anything because that is completely different to set up. But as you can see, it's pretty easy to set up just a simple jumping thing like that. So you may be wondering, well, how did you get it to work for something like this, where the terrain is not, or the floor isn't just like a flat plane? And the way that I did this is actually, it's kind of out there, but I'm going to show you guys anyways, because this is pretty much how you're going to have to do it if you have any terrain that's like this, where as you can see, it goes up and down. So I have a sprite here. What this sprite is actually doing is it is generating the terrain object. So I'll show you what I mean by that. So here's an example of one of the terrain objects that it generated using this code here. If I just go ahead and export this, and we go into a website where we can actually view an OBJ file. I'm going to change this .txt to an OBJ so that we can view it. And I shouldn't have closed that. But this is what it's generating, okay? So as you can see, one piece of the terrain by itself, essentially I'm having it generate chunks of the terrain at a time, and it can load those and unload them depending on where the player's at. So I'm going to click wireframe on this tool and just show you exactly what I mean, or exactly what this sprite here is doing. So what it does is it's generating points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points, or 10 vertices, and it does that on the X and the Y, or X, Z, you know what I mean. Then for each of those points, I plug in where they're actually at in the world into a function And this function looks like this inside of Scratch or inside of TurboWarp here. So it's basically just a sine wave interference based on the x and y of that point. We have it based off of a whole bunch of random numbers, and then at the end it returns that value, or it actually returns the value divided by 3. If, for example, I have it just divide by 1 and we run this, as you can see, the terrain is just much more amplified because the final value is going to be 3 times what it normally is. But yeah, 3 is the value that I stuck with because it's pretty nice for what I'm trying to show off here. So yeah, it plugs that position into that function, and when you do that for all the points, you get something like this, and that is essentially it. So to get gravity and jumping and all that to work, obviously you need to know what the height of one of these points is. And so what I did is I just took this function block that returns how high up you are in the world based on the X and Z position, or X and Y. It's actually mislabeled. And then inside of the 3D engine itself, on the controls block that I have here, it actually plugs that in based off of the camera X and camera Z positions, which is essentially the player position. And that is going to be setting it to the variable called ground Y. Okay? So to show you what that means, when we walk around in the world, as you can see, that ground Y variable that's up here is going to be changing just based off of where we are at. And that correlates directly to the height of the ground at the player's position, which is why it moves us up when we're up on a hill. And if, for example, we go down here where this water is, we're actually down lower. So it's negative almost 500 here. When we come up here onto this hill, it's almost positive 200. So you see what I mean? Pretty cool. So essentially, if you are able to always know the height of the object at a position, and you can plug that in to where your player is at, you can use that to determine where the ground is. And then just like in the demonstration that I showed you guys with the house example, where we built the jumping, I basically just have something like that set up where you cannot go below this ground Y variable here. So again, it looks a little different, but this is actually the same thing that I was showing you how to build in the other project. But obviously, instead of this just being 0 here, like we had in the other project, we're substituting that for the ground position, or the ground height. In the video description, I will also leave a link to this project, because it is cool if you just want to mess around with some of this stuff, or see what I've made here so far. This is actually pretty crazy for being made in TurboWarp. It's not perfect. As you can see, it's running at just about 50-60 FPS, and the trees and stuff don't generate on one side of the map. They only generate on positive chunks, which you can expose by clicking that chunk position. So as you can see here, as soon as we go to 9, -1, if there's a negative value there, it's not going to generate any objects like trees or anything. But this is infinite. So crazy stuff. The third person model, like this guy that we have here, that moves based on like how fast you're going, you know what I mean? This took like 7 hours just to get this guy like to work in this. So keep that in mind. That might have to be a long YouTube tutorial when I do show how to make a third person controller. Essentially what I had to do was take each individual body part as an OBJ file and then bring it in and make it turn accordingly, because there's no built-in animations. So you pretty much have to have everything happening in real time. So it's ridiculous. But I will try to show that off eventually. It's a lot. Now, of course, what a lot of people want is to be able to like hold something in their hand. And that's actually pretty easy to set up as well. So I'll just show you that real quick. I'm going to, first of all, create a new mesh. I'm going to take it from this right here. We're going to name it hand. So change all of those. And then you can make a new list. That seems like the way that they want you to do it, but it's not really practical. The way that I do it is I have it load into a list every time. But for simplicity's sake, we're just going to make a new list, call it hand. And so in previous videos, I've showed off how to download OBJ files from Polycam specifically, but you can get them from wherever, or you can make them yourself, which sometimes is more practical. But right here I have an OBJ file that is just like a gun. And so what we are going to do is, I believe it is this txt file. We're going to open that into the list, and we can just hide that for now. So set our hand from obj.mtl, set that to the list that's called hand. And then also what I'm going to do is import the texture for it, which will look something like this, especially if it's from Polycam. It is just the material that we're applying here. And we're going to have that texture set to that new costume that we have there. And we can just put this right below where it loads the actual house or the map here. And next time that we start the project or click the flag, that's going to begin loading that mesh. So down here on the render block, I'm just going to put that in a wrapper and duplicate it. And we are going to type in hand right here, and I'm going to remove this rotate thing and just put it right below there, and I'm going to restart and see where we're at. There it is. So I might make it a lot smaller. So I'm going to move it up a bit, and there we go. So we have this object loaded into our scene, which is great and all, but obviously if we're holding it, we want it to actually like be on the screen and follow like the player position, and that's simple. So first of all, before we scale it up, we are going to have it move to camera X, camera Y, and camera Z. Scratch camera Y for now. And there you go. So now it is following us at all times. But obviously, we want it to be pointing in the direction that we're looking, which means we just want to rotate it around based off of the camera direction. So rotate around Y by camera rotation Y. And then obviously when we look down, we want it to look down as well. So rotate around X by camera rotation X. We can now turn it in any direction, but as you can see, when we are looking down, it is not rotating at the correct point. So we need to have an offset at where it is actually rotating. So you can keep messing around with this, but typically just having it rotate is going to be difficult. So there's a better way to do this. So I'm going to remove all of this and stop our project for a second here. Start with no transformation. Obviously we need to scale it up. So I'll do something like 888. And then we need to do a transformation. So what this does in Simple3D is basically you can configure what type of coordinates we're using here. So for what we're doing, if we go from view space to model space, that is going to be where we are already at in the world. So it's just going to make it a lot easier. You don't have to have it actually tied to the camera X, Y, and Z location. We're also going to add a move. And for the X, Y, and Z, we're going to put transformed X, transformed Y, and transformed Z. So finally, we also want to rotate around X and Y. So we want to rotate around Y first, rotate by camera rotation Y, and then for X, camera rotation X, just like that. And then draw mesh hand. And as you can see, look, it's locked to our screen. And I already changed this a second ago, but this is going to be the position that this gun is at. So if I set this to... So if I set our Z position to like -7, and then we scoot it over on X and the Y. So 3, -3, and -7 looks like it is pretty good here. And that is going to lock it right there. What I did in this example project is actually pretty neat. So obviously you can have it also rotate based on where the player is moving. So I actually made a new list, which is called gun ADS. So when you hold the right mouse down, or the right click button on your mouse, is going to set those values to 0.15, -4, -4. And then if you let go, it is going to be about 3, about -5, and about -7. Okay? And as you can see, that is basically being controlled right here. So 0.15, -4, -4, 3, -5, and -7. All right. So if the mouse is down in our project, or if else, we can change this to -2, -3, and I forget what the first value there was. Looks like 0. Okay. And let's just see what that does. So obviously there's no interpolation in between. But you can see when we click, it is sort of like we're zooming in. You know what I mean? So I'll also leave this project or like a download link for it, just in case you guys want to see how I did this, or if you want to copy this over into there. It's pretty straightforward on the player sprite here. Like I said, it just sets that variable, and then in the engine itself, it is interpolating those values. Okay, pretty easy, pretty straightforward. You'll just have to take a look at how that's being done, but it is pretty simple. So a really easy way to do this, or to add the bobbing when you're moving, is, since we have a velocity for the player here, maybe that goes up to about 0.45 when we're moving, we can use that and implement it, just for an example. So if we take that variable from the player, the velocity, multiply it by the sign of the timer, which, as you know, is always increasing, and we'll multiply it by about 95, the timer. Take that sign and multiply that by about 5, and then have it multiplied by the velocity, and we can add that to one of these rotations. So for example, if we do camera rotation X, most likely, when we walk, it is going to bob a little bit. And so you might have to increase this. I'm going to try like 379. Okay. And that is pretty much how simple this is. Of course, you can also add that into where it's actually located at. So take out the camera rotation X and set it to -3, for example. If we put it there where the position is at, that's a little too much, but you You get what I mean? I'll set this timer variable to like 578. Now when we're walking, it sort of bounce up and down just a little bit, just a little, you know, subtle movement there. And you can also have that set up for the strafe velocity, affect the X. So now when, I mean, it's a little weird to set it up like that, but you get the idea. Okay, as you can see, it's really not that hard. All of this is going to be based on what you want to do, so you can tweak all these variables and change certain things as well. Again, thank you guys so much for watching. If you do enjoy content like this, don't forget to subscribe and come back and check for future videos. Even if this isn't something that you're considering doing, I think that it's cool to learn how to do this stuff, or at least understand what's going on behind just the visual side of things, because there's a lot of mathematics and code that goes into this. And just the fact that something like this is possible inside of TurboWarp is absolutely mind-boggling. So I hope you guys enjoy. Make sure to like, and I'll see you in the next one. Later.